All right. Announcement first. In case you haven't seen the Moodle announcement here, lab number 2, the new deadline is next Saturday. However, we're going to release lab number 3 very close to Wednesday. So I would suggest finish that as soon as you can, even though we'll close the submission for lab number 2 only on Saturday next week. But you're going to work on lab number 3 next week. Okay, for your midterm written test, if you look at the syllabus, it's October 24th, Wednesday. It's going to be, so that means when you come back from the reading week, the first class will be October 16th, and the second class will be October 18th, right? Okay, that's kind of the schedule. It is, I will let you know after the reading week, but, questions?
Yeah, when will the submission for lab be?
I will try to open that maybe tomorrow or over the weekend, so I'll let you know, yeah. Okay, so for, when you come back, so the Tuesday for October 16, over here, the stuff will be covered in the midterm, okay, because you got more than 1 week to prepare. And for October 18, I will confirm with you, but for sure, October 16. So now there's something I want to ask you guys for this section here. Would it be useful to hold a review session during the reading week?
Yes.
Okay, good, okay. How about we do one? Can next Thursday work? Just a normal class time, how about that? Okay, any objection?
I have a question.
Yes.
Can you record that?
The review session, I'll record that in case you cannot make it, all right?
Yeah.
Okay, how about I'll confirm with you, so next Thursday, this time, okay, review session. It's basically just ask questions up to what we're gonna cover today. And, yeah. And we'll see, once we cover the topics for October 16, if you need another session there, I can hold it too, but we'll see. Yes?
Are you going to be covering topics in the survey?
With the survey, what do you mean?
You remember you posted the survey last night, and then
For review session, what?
the survey that you.
Yeah, yes, we're gonna do the survey today, but yeah, nothing to do with this. Okay. Okay, guys, if no question, let's go to the topics. Okay. I do want to get to the heart of the inheritance today. Okay. So basically, this might be a little bit repetition depending on who you took with for 2030. But I'll just assume everybody maybe know a little bit about polymorphism, dynamic binding, but maybe I'll try to cover just from my perspective to give you details, okay? Okay, let's see how much we can do today. All right, so let's review very quickly what we got from last time. Basically, from what we got from last time, we designed these two classes, 3 classes actually. So we got basically the first class, we have a class called students. That's basically the superclass for another subclasses. Student at the top, and also we got resident students, which inherit from students. And also we got another class called non-resident students, which also inherit from students, okay? Let's just, rather than see the code, let's just see conceptually what you should understand for the rest of the lecture, okay? And then we'll go from there. Now, we have a class called students over here. So this is the superclass or parent class, okay? And then in the student class, we define some basic features for a students. We got name, we got a list of courses, and also we got a command called register, and also we have a query to calculate the tuition, the base rate, okay? That's a student class. On the other hand, we got 2 subclasses. We got non-resident students, and also we got resident students. Each one of them will inherit something from their parents. At the same time, they can redefine certain features. Let's see very quickly. Okay. So now let's say for resident students, the new feature they have is something called premium rates. Okay, which means we're going to charge them a little bit more since they live on campus. And also, we can set a premium rate for their students. Symmetrically, for non-resident students, another subclass, we got a new feature called discount rate. Okay, and also we got set discount rates. So you can see these 2 features are different between the 2 subclasses. Now, for the tuition feature which we inherit from the student class, we try to redefine them with the class-specific or subclass-specific feature. For example, in the case of resident students, the way you calculate tuition over here is by using the premium rates that's only specific to resident students. On the other hand, when you calculate the tuition for non-resident students, you have to use the discount rate. Okay? That's kind of our starting ground for today. Any question about this? Of course, you're expected to use inherit and also using precursor to implement this design. Okay. Now, I want to go straight to something very important today. Let's consider the following 3 declarations of variables. Okay. Basically, what I'm going to talk about is something called expectations. For you as a client, whenever you see certain declaration of a variable, object variable, what can you expect from them? Okay. So what do I mean by expectation? Basically, expectation is the range of features you can call on that particular objects. But how do we define the expectation? Let me show you. Let's consider 3 declarations here. I have an object variable called S, another called RS, and another one called NRS. Okay? Let's have a look at their type. For the first one, I declare the type of student to be as to be just students, and the second one to be resident students, and the third one to be non-resident students. So these are basically different types, right? One thing to mention very quickly, whenever you declare a type for a variable over here, it's called static type. Static in the sense that you shouldn't modify that. Well, actually, you are not allowed to modify that. It's always fixed. Once you declare S to be of type students, it never changes that. Okay, it's static. We'll talk about dynamic in just a moment. So now we have basically 3 object variables over here with different static types over here. That's what we are dealing with. Now the question is, depending on the static type for these 3 variables, does it affect the way we can use these 3 variables? That's the question. The answer is yes. Okay? Let's see how exactly it is going to affect. Let me ask you the following question. I'm going to write it down, and then you can tell me whether things will compile or not. The first one. If I say, for example, S dot name, would it compile? It would, right? Because somehow you can see students was defined over here. It does define the name attributes, okay? Similarly, if I say S dot, I'll say CS for courses. If I say S dot register and also S dot tuition, all of these should compile because 1, 2, 3, and 4, they're all there. Let's apply the same reasoning, okay? If I say rs.name, should it compile? In this case, that would be, even though name is not explicitly defined in resident student, but was simply inherited. Similarly, we got rs.cs, rs.register, and also rs.tuition. Okay, so far so good. Let me, similarly, I can also say nrs.name, also nrs.courses, nrs.register, and also nrs.tuition. So far so good. It seems like all the features we define in the superclass is available in all the 3 variables. Here comes the critical part. Okay? First of all, let me try something easier for you to see. If I say rs dot premium rates, that should compile because premium rate is defined exactly here. Okay? Similarly, if I say rs dot tuition, that's also fine. Oh, sorry, not tuition. What I meant to say was set premium rates. That's also defined over here. Okay, symmetrically, if I say NRS dot discount rate, DR, it is defined exactly in this class, explicitly. If I say NRS dot set discount rate, that's also fine. Here comes the issue. If I say the following, let me use a different color. If I say S dot premium rates, would it compile? Okay, you would say no. However, let me ask you the following. Let me write a line over here. So let's say I already declare S to be students. Now let me create objects over here. If I say create a RS for resident students, okay, just standing for resident students, and then S dot make, like that. What I'm saying is S, even though it was declared as a student object, but it is actually pointing to a resident students objects, which must have a premium rates attributes, something, okay? Now, after this line here, if I say s dot premium rates, would it compile? Yes, no? Okay, I heard some, it should, okay? Yeah, we're still dealing with compile time, right? So one thing to note, for those of you who take about 2001, towards the end, you learn something about undecidability. So compiler basically statically can only determine if one program will compile depending on the static types of the variables. It can never keep track of the dynamic type. Even though in this case over here, we know that dynamically speaking, if you execute a code at the runtime, if you execute this fragment of code in runtime, S will actually point to a resident student objects, but the compiler doesn't know about it. Okay, it's just an undecidable problem. The only thing the compiler would know is S over here was declared to be a student objects. So you can only call the features on S that's already defined explicitly in this student class. That's it. That's why you cannot say s.pr. If you really want to say, I am so sure S is pointing to a resident student's objects, but I really want to call that feature there because premium is really there. You have to force the compiler to believe it using a typecast. That's kind of the story, but we'll get there. I'm just trying to give you a preview. Okay, so now let's apply the same reasoning here. If I say s dot set premium rates, that shouldn't compile either, right? Similarly, right? Because you can see set premium rates is simply not defined in the static type of the students of S, okay? Now, let me ask you this. What about I said over here, rs dot discount rate? Would it compile? Well, again, if you want to know exactly how the compiler is going to make a decision, look at the static type. Over here, rs is of static type resident students. Resident students is over here. Does resident student have the feature called discount rate? No, it doesn't. So this wouldn't compile. Okay, that's kind of the overview of expectation. So again, expectation is really about once you declare a variable to be of certain type, how do you know what features you can call on the particular objects? The answer is look at the static type. If you go to the static type to see whatever feature that's already declared over there, that would be the ones that you can expect. Okay. That really will affect the way we talk about polymorphism, okay? Okay, any question about this? Just a very quick summary before I go further, okay? Okay, let's now go to this particular, okay, it's this slide over here simply just try to tell you that summarize what we did last time. Whenever you use inheritance, one aspect is to use code reuse. You can try to define new feature. You can try to redefine existing feature inherited from the parents. Okay, so these are the two purposes. So now what I would like to do is to show you some quick syntax before we go to polymorphism, dynamic binding. Okay, I just want to remind you something about the syntax over here. Static type is what you declare at the compile time. And that's something the compiler will actually keep track of. That's easy. Just look for the declarations. On the other hand, dynamic type might change in any arbitrary way or complicated way as you go. So it's simply not possible. It's an undecidable problem. Okay? Let me show you a quick syntax. In Java, you can see that on the left-hand side over here, you're trying to declare S to be of static type students. Okay? Green one. And then on the right-hand side, after the new keyword, you're saying that at this moment, I want to create a dynamic type for S to be just students. So in this case, the two types happen to be the same, but they don't have to be the same. The second line, you can see the static type is actually students over here, but the dynamic type is resident students. Okay, they can be different, just syntactically. How do you do the same syntax in iPhone? The concept is exactly the same. Just the syntax, you have to be a little bit more careful. Okay, let me show you here. Let's talk about syntax so you wouldn't get confused. Page below. Okay, let's say this. Let's say in Java, if you say students, S is assigned to new resident students. Okay, let's say that. And of course, you can give a name. For example, Alan. That's in Java. How do you translate that into iPhone? First of all, we know that this is the static type. And also this is the dynamic type. Okay? So now how do we translate? Translation is easy. First of all, you have to declare that you may have a local block over here. You would say S is of type students. Okay? Basically, this part is this part here. But how do you create it? This is how you create it. Maybe you have a do block over here. You would say create, and whatever that goes into this curly brackets will be the dynamic type. So I can put RS over here. Okay? And then S dot make. So this part is the static type. And this part here is the dynamic type. And they are different. Okay, one more thing to show you. In iPhone, they allow you to simplify things a little bit if there's a special case. Let's say if I got another one, let's say students, let me just say non-resident students. Non-resident students, NRS is assigned to new non-resident students, and maybe mark over here. Okay, you can see here the static type and dynamic type is the same, right? You can definitely do things like this. Okay, let's say I say NRS of type NRS, like that. Okay, there are two ways you can write it. You can either say create NRS dynamic type and then NRS dot make, right? That's one way to go. Or you can simply simplify that to be just create NRS.make, when they are just the same. Okay, there are two ways to write it. Let me just highlight it. NRS here, just the same as the NRS over here. When they are the same, you can simplify that, yeah. Yeah, I'm just assuming that you have a constructor in the students called make. Of course, you may pass the appropriate arguments over there.
Is that the make feature in student or make feature in RS?
Okay, good question. So the question was, where should the make feature come from over here? Because NRS was declared as of type NRS, so it comes from MRS. It's the same. S is of type students, so that should come from students. Yeah. Okay, guys, any question about syntax before I move on to some ideas?
So I know that static in Java is a keyword. Is it the same as?
No, different. So the static type I'm talking about has nothing to do with the static keyword in Java. It's different. When I talk about static type, the definition is easy. Whenever you try to declare a variable like this, I say S is of type students. That's a static type. Okay? And then whenever I try to create an object at the runtime, that's the dynamic type. Static versus dynamic. So don't get mixed up with the static keyword in Java.
What if the class?
Huh?
What if the class is static?
No, let's not talk about static class over here. So you don't have static class in this case. All right. Okay, guys, any question about the syntax here before I move on? So whenever you see anything like that in iPhone, you got the same concept in Java as well. Nothing new here. Okay, after this, let me just go to the slides and let's talk about some intuition. Okay. Now, basically, this is a table for you. How about we do some little bit exercise over here? Have a look at this decoration. So let's say we got S1, S2, S3 of static type students. We got RS, static type resident students. Well, NRS, also static type non-resident students. You can see that over here, I'm saying S1 has the dynamic type students, just the same. For S2, we got dynamic type resident student, just happen to be different. For S3, the dynamic type is non-resident students. Okay, so far so good. And then for RS, I just say the dynamic type is simply resident students. For NRS, the dynamic type is non-resident students. Now here, I would like you to think about this table. Let's just do one row together, and you will get an idea for the other row. Let's say these are all the features available in the whole inheritance hierarchy over here. We have name, we have courses, register, tuition, premium rates, set premium rates, discount rate, and set discount rate, etc. Okay? The first one I would like you to think about is S1. Okay? What about S1? Which features can you call on S1? What about what can you not call? PR, right? Premium rates, set premium rates, discount rate, set discount rate, because that static type is there. Okay, good. This one is maybe a little bit too easy. What about S2? Okay, just do S2. Would the case for S2 the same as S1 or different? Okay, let me give you a little bit hints over here. S1 and S2, their static types is the same, students, the green one, agree? But the dynamic type for S1 and S2, the red ones, they are different. The dynamic type for S1 is students. Dynamic type for S2 is resident students. So now my question is, if we want to fill in the second row for S2 dot, is it going to be the same or different? Wow. You know, I'm pretty sure I need to have this discussion today, right? Since you guys may be a little bit confused. That's good, okay? Okay, here's number one principle. Whenever you have something to decide, like whether a feature call is valid or not, whether they should compile or not, only look at the static type. Pretend you're the compiler. Only look at the static type. So now for S2, I don't care what the dynamic type is. Doesn't matter. Only look at its static type, which is the same as students. That means I will get just the same. This might be counterintuitive to you. This might be. Okay? Make sure you fix that. Okay? Again, whenever we say an object dot something, what that something can be depends on what's the static type of the objects. The principle just as easy as that. It doesn't matter what its dynamic type is. And we'll get some intuition in just a moment. Okay? Okay. Now, similarly, what about for S3? Now, S3, even though it's of static type students, but its dynamic type is different. It's non-resident students. Would it be the same or different? Same. Thank you. Good. The same, just like that. Okay? Now, what about RS? Yeah, everything but except for the last two, right? Because for RS, the static type is resident students. It should be all the features in that particular class and all the features inherit from the students, but not its sibling class, like a non-resident students. Good. Okay, you get the idea. That's it. Okay, and then for NRS, it's the opposite, right? Okay, any question about this for now? Okay. Now, let's get more intuition about polymorphism before, yeah, go ahead.
For the S2.
S2, sure. Why can we not call PR? The reason is this. Even though for S2, the dynamic type happens to be resident students, however, the compiler has no idea about the compiler has no ability to keep track of the dynamic type. So the dynamic type is irrelevant over here. Okay? To be more precise, it's an undecidable problem. So if today I tell you that to the class, if you can write me a program to say, take any arbitrary program of Java, like this. Let me make him. Okay, let's say this. Now, if any one of you can write me a program which will take either something.java or something.e, doesn't matter. I have a program or Java program. And then you will give me one input is like that, a file. Another input maybe just some variable x. And the output is very simple. Tell me what's the last dynamic type x was in the before the program terminates. Okay, so this will be, if this is something you can do, you get an A+ for this course. The truth is, if you actually can do this, you deserve not just an A+, you deserve maybe something like a Nobel Prize. Because it's simply not possible. Let me tell you what intuition is. Okay? Let me give you one example where you can easily figure out. For example, if the program is simply like this, let me write it in Java for you, if that feels more comfortable. I can say, students, you simply just say students, S is assigned to new resident students, something like that. And then the input would simply just be let's say this is one of the input. This is input number 1. And input number 2, I'll simply say, what's this last dynamic type for S? In this case, the output should just be RS. Agree? Okay? But in general, you just cannot do it. What about this? If I do the following, let's say I give you another input. While true, students as new resident students. What about that? If that's the input, the best your program can do is to simulate the way it runs. That means your program will never halt, will never terminate, so you will never get the answer. That's kind of the intuition. Because I'm talking about any arbitrary program of Java or IFO, and it's simply not decidable. Okay? So the point is, whenever you want to decide whether a line of code compiles or not, you don't worry about the dynamic type, not at all. Okay? Just a static type. Okay. Good. Let's go back to our slides over here. So now let's, any more questions about this table here? So the decision making is very easy. Only look at the static type of the variables. Okay? Now, assuming that you kind of get the idea here, let's go a little bit further to test your understanding. I want to give you some intuition about polymorphism. Okay? And let's do the following code. Let's say we have two variables over here, S and RS. S is of static type students. RS is of static type resident students. And I simply create some student objects, Stella. And dynamic type is just the same, just student, right? That's why I can omit that. Line number 6, I create a resident students object called Rachel. Okay? Now, I have a question for you. And then also set the premium rate to be 1.25 for the resident students. I have two possibilities for you. Either I can say S is assigned to RS, or RS is assigned to S. Now, the question to you, which one should be valid and which one should not be valid? First one is valid, and the second one is invalid. I agree, that's good. You guys get the 30, at least you can answer it correctly, that's good. But can you tell me why? What's the reasoning? Specifically, I would like to know why line number 9 should not compile. Why? You deserve to know why. Can anybody tell me? Wouldn't compile. Okay. Anyone?
All resident students are students, but not all students are residents. Oh, it's the opposite. All resident students are students.
Yeah, I see what you mean. You say all resident students are students, but not the other way around. I agree, but it's not the direct answer.
You're saying students can be used as resident students, which is not true. It doesn't have all the features of resident students.
Okay, that's good. That's getting somewhere. Okay, let me just rephrase what you just said. That's basically correct. Okay, let's think it this way. Okay, this is really important over here. Okay, let's say this. As soon as I declare S to be of static type students, we know that we can call all the features from the student class on S, right? As we learned before. For example, S.courses, S.name, but definitely not S.premium rates. It's not possible. Okay, similarly, when we talk about resident students, we know that our expectation on that, on its static type, is something like this. I'll just enumerate that. Okay, if I say rs.name, rs.courses, rs.tuition, and also rs.premium rates, rs.set premium rates. That's what we have. Okay, now let's talk about specifically why line number 9 wouldn't be so possible. Okay, basically what line number 9 is saying the following. Let's try to draw some diagram here quickly. Okay, so we got S, we got RS. S is pointing to some student objects. And we know for each student object, we got name, we got courses, and that's it. Okay. On the other hand, for each resident students objects, RS over here, we got more attributes, right? because it inherits, not only that it inherits from student, but also got some new features. In this case, RS is pointing to some RS objects. We got name, we got courses, we also got premium rates. So this is a new bits. Agree? Okay, now let's prove by contradiction. How do we do that? Let's assume if line number 9 was okay. Let's assume. If line number 9 was okay, that means we're going to do this assignment over here. And what's the consequence of that? That means RS, rather than pointing to this RS object here, RS is going to point to this student object here. Okay, so far so good. And what can we expect from RS? For example, rs.pr. Now, in this scenario here, if we say rs.pr, what's going to happen? Well, basically it's a crash, right? Because rs.pr is simply not defined on the student objects. Okay, you can see that this is simply not going to work. Okay, so that means our initial assumption that this should compile is not true, so it shouldn't compile. Okay, that's kind of the reasoning. So again, it's all about expectation. Whenever you see any variable over here, it tells you about the expectation. How do you know the expectation? Go back to the class declaration and see what the features there are. Okay. Any question about this? Are we okay? Yes, question. Oh yeah. So basically, yeah, you're right. So let me complete the picture. Basically, yeah, no problem. So let's say, let me just do another one. So we are saying that line number 9 should not compile. Okay, we just proved that. What about line number 8? The reason that it should compile is because like this. Let me just draw that properly. Okay, so let me use a different color here. Again, S was used to point to a student objects over here, and also RS pointing to a resident. Oh, let me just draw it. Pointing to a resident students objects, and over here we got name and courses. Name, courses, and PR, premium rates. Okay, so now line number 8 is over here. We do the S is assigned to RS. So that means S, rather than pointing to here, it is going to point to a RS objects. So now, are we going to be in trouble ever? Think about it. What do we expect on S? To know that S was declared as a student. So all we can call will be S.CS, S.name, and also S.pr is not even going to compile, so that will protect us from that. Okay, so that will be safe. So we will never ever access these premium rates directly. The compiler will simply disallow that. Okay, any question about this? So you have to know why line number 8 will actually compile, and why line number 9 will not compile. You should know the reasoning. Yes, question.
Here the file does not allow us, and there it crashes. So
which one? You mean line number 8 and 9?
between 8 and 9.
Between 8 and 9? Okay.
Yeah.
Basically, you got to think about the main point for you to consider is what happened after the assignments, right? Let's say for line number 9. For line number 9 here, over here, okay, if we try to do that assignment, let's say we allow that. Let's say we did allow that. That means RS is going to point to a student objects afterwards. Agree? And we know that every student object only got name and courses. They do not have premium rates. Agree? And we also talked about before, the static type for each variable tells you what feature you can call on them. Right? In this case, RS is of static type resident students. Right? That means the user, the client, is expecting to call something like rs.pr. But what's going to happen here? If you say rs.pr, do you have a premium rate over here? You don't. So that means that's going to crash. It simply there's no such field for the objects. So that's why the compiler will simply disallow this in the first place. Okay, that's for line number 9. What about line number 8? Line number 8 follow the same reasoning. Let's do it again. Okay. For line number 8, we're basically doing the following. Let me just highlight it in the same way. We're saying that S is going to be assigned to RS, right? So now it is going to point to an object of type resident students, okay? And now you can think it this way. You're basically expecting a students over here, and what can you expect from the students? Well, you can call courses, you can call name, but you never expect to call premium rates on the students. So this line is never going to happen, right? So you're properly protected by that. So now, if you only call s.cs, s.name, you're always going to retrieve name and cs from here. So the premium rate is just never used directly. That's why. Okay? All right, any question about this?
So polymorphism only works for static types?
Polymorphism is decided somehow. Yeah, polymorphism is more like a static type, static compiler time feature. You can assign different types of variables to another variable. We'll get there. Yeah. Dynamic binding will just follow a little bit later. Any questions? Are we okay? Yeah. Okay, after this, let's go on to the next one. Okay, the complete reasoning, as I just argued, is on the slide. You can read them through. That's more formal. Okay, but you should really get an insight. Now, after this, let's talk about some reasoning for, well, dynamic binding in some ways is easier to understand. Okay, let's talk about dynamic binding. Let's say this. Let's say we have, let me just use iPad. That might be easier. Let's say that's the code we have. Let's consider them. Let's say we have a course object here, EECS3311, and then some marks over here. And then we have S of static type students. Okay? And now let's say we try to create resident students objects and non-resident students object. Let's just do that quickly. So what I'm trying to, let's say for this line here, what do? RS is pointing to a resident students objects. And the name is simply just Rachel. The second line over here, we're creating NRS to be pointing to a non-resident students objects. And let's put it here. Non-resident students objects. And it's Nancy. Okay, let's do a little bit more. When we say rs.set premium rate to be 1.25, rs.set premium rate to be 1.25, I'll just say 1.25, so you just remember it's premium rates. And then we say rs.register course C. What I would do is, there it should be some courses array, and then you should point to the array over here, and then we simply just register for 3311. Let me put the 3311 object here also in the context, okay? When we first create this line here. So that'll be course, and then we got EECS 3311, and then 100, okay? And then the first course of this particular resident student is registered for that course, okay? That one there. And what about this line here? We set the discount rate for NRS to be 0.75. So 0.75 over here for the discount rate. And then the courses is also going to point to an array of courses. And then the first course is just the same, okay? Because we also try to register for the same course. Okay, that's just a setup. Now, here comes the thing. We know from before for polymorphism, if we say S is assigned to RS, we know that that should be valid for the reasoning I just said a few minutes ago. If we do this, what's going to happen? Oh, by the way, S is simply what we'll just declare, so I'll put S over here. Okay. Let me use pink over here. After this, when I say S is assigned to RS, we know that that should be valid. So S is assigned to wherever RS is pointing to. Okay? At the moment, we say that the static type for students remains to be students, S. What about dynamic type? Well, it's pointing to an object of type resident student, so that's the dynamic type. Okay? And now, if we say S.tuition, what's going to happen here? Well, in the diagram, it's quite obvious to you because since we are pointing to a resident student's objects, so we know that we should really apply the premium rates into the tuition calculation, right? In which case, we'll simply say, okay, this is the only course they are taking, so we'll simply do 100 multiplied by 1.25. So you get 125. That's the tuition. Okay? Now, what if we go to the next line? We do some reassignments over here. We say S is reassigned to NRS. So that means S is not pointing to here anymore. It is simply going to point to wherever NRS is pointing to. So now the question for you, has the static type of S changed? No, remains to be students. What about dynamic type? Non-resident student, right? Because you're pointing to a different objects. So dynamic type might change, static type never changes, okay? And now in this case, if we simply try to call the same feature over here, S.tuition, okay? You can see that now we're going to apply the discount rate over here, okay? And then in this case, we're simply going to calculate the same course, 100 multiplied by 0.75, right? Just different value, okay? One more thing to mention to you. The very essence about dynamic binding is, if you go back to here to look at the diagram here. If you look at the diagram here, how many versions of the tuition feature do we have? How many? 3, right? Okay, you got one version over here. You got one version, let me highlight it. You got one version here. You got, that's not a good color. One version here, one version over here, and the third version over here, okay? So now you can see that if I simply say students, if I only make this declaration, basically what I'm trying to say is I can expect any client to say S.tuition. That's from the compiler's point of view. That means since the static type over here already declared this feature, it's guaranteed to be available, either in this class or in any of the subclasses. But dynamic binding goes a little bit further at the runtime to say, at the runtime, S might be pointing to different types of objects. S might be pointing to maybe, oh, not here. S might be pointing to a resident student's objects, or it might be pointing to a NRS objects. Depends, right? Depends how you do the reassignment for the objects. Now, if you happen to point to a resident student's objects, you have to know which version of the tuition feature will be called. In this case, we know that because the dynamic type is resident students. So we know that if you go back here, this version will be called. Only this version. On the other hand, you can see over here, in the second scenario, if S is currently pointing to a non-resident student's objects, now the dynamic type has changed to a different type. So now which version to call at the runtime depends on what the dynamic type is currently. In that case, it should be the version in NRS instead. Okay? So we talk about both polymorphism and dynamic binding in an intuitive sense. Does it make sense to you? Okay? Okay. All right. Guys, any more questions about this before I move on? So we'll see more examples. Yes?
So you can do S.tuition because tuition is defined in student?
Correct, because student is a static type.
Okay,
Yeah.
so if I had, let's say, rate defined in student,
Yeah.
can I do, like after I do S is equal to RS, can I do S.set rate?
You mean rate as in student class?
Yeah, as in like,
Yeah, I see what you mean. The question was, what about this? Let me just say a little bit more general, okay? You're basically saying that, let's say I define a new feature. Let me use a different color. In the student class, I just define a new feature f of type double or real number. Okay, and then we also got maybe another new feature called set f. And also you will take a command. Okay, let's say we got these two new features. Let's say we choose not to redefine these two features in the two subclasses, which means they will simply inherit as is in the superclass, right? So now, your question was, if now let's say I got S of type students, okay? So now if I say, in the next line, I say creates resident students S dot make, and now after that I say S dot F. That's what your question was, right? Okay, now which version is it going to call? Well, there's only a single version in this case, right? The single version is only this version that's already in the student class. It's simply inherited to the subclass. So in this case, you will simply call the inherited version. of students. Okay? Yeah.
I have one more question. So
Yes.
let's say F was set rate, and then I redefined the set rate in resident students, and I did it whatever the rate was times 1.75.
Okay.
Can I do S dot set rate when I not cast it, when I set S equal to RS?
Okay, sure. So you're saying that basically you say set F, and then you try to redefine set F, right?
Exactly.
Okay, sure. Sure. Let's say in the resident students class, we also say set F. No problem. Let's say that. Let's say we do that. Okay, also take a real. Okay, let's say it's redefined. Redefined, I would say plus plus means redefine. Okay, so now in this case, let's try the following. Let me go back here, and then I try to say S dot set F. So now, first of all, how many versions of set F do we have?
Let's say it's in all of them.
All of them? Oh, you want to redefine this as well? Sure.
It's there too.
Yeah, we can do that.
And let's say before the S dot set F, I say S is equal to RS.
Yeah, we can do that. Okay. Let's say for set F, version number 1, version number 2, version number 3. We got 3 versions here, right? Good. Okay. And then what we will do is, let's see over here, RS of type resident students. Okay. And then what we'll do is create rs.make. Okay, so now we got rs, we got s. Okay, so now good. If I say s is assigned to rs, okay, if I simply got this line over here, what's the dynamic type for s? rs, right? We're just reassigning that to another object of type rs. Good. Now, your question really is, if I say s dot set f, okay, now question is, which version of this set f is going to be? Well, it should be rs, right? Because which version to call depends on which dynamic type it is. Yeah, so hopefully that clarified that. Okay, good. Okay, guys, again, whenever you want to see whether this particular feature call is allowed or not, look at the static type. You want to know which version will be called, look at the dynamic type. But which version will be called is only determined at the runtime, not at the compile time. Okay, good. All right, let's go back to the slide and see what else to say. Okay, you can see exactly what I said. So now what I would want to do is I would like to just go a little bit slide reading, but I'll try to give you example along the way so that we can have a common ground to discuss. Basically, what I want to tell you is, I want to show you different typing rules that you have to know in order to analyze polymorphism and dynamic binding. Okay, so let's go from the basics here. Okay, let's see just from here. So we talk about a type. Type is really about runtime values. Okay, so if I declare S of type students, that means there can be many runtime values for the students' addresses, or it can be runtime addresses for resident students. Okay, just type. So now, what I want to show you is we do have inheritance of hierarchy for classes, which I want to use a new one to show you over here. Let's say we have this new hierarchy over here. Okay, let me just go over that very quickly because that's just another thing that's going to occupy most of our examples later. Let's say we have a smartphone example over here. Okay, at the top level we have smartphone. Okay, and in the smartphone we only define 2 basic features. We have dial, we have surf web, 2 basic features, which means these 2 features are guaranteed to be available for any static type smartphone. Okay, and we have 2 subclasses directly under. One is called iOS, the other one is called Android. For iOS, we have a feature called surf web. Okay. Oh, actually, in this case, surf web is redefined. Let me just highlight that to you. You can see over here, surf web is actually defined in the smartphone class. And then we are trying to redefine that in the iOS. Let's say usually when you surf web in iOS, you use a Safari, right? On the other hand, if you also redefine the surf web for Android, maybe use Firefox, just different way of doing things, okay? So these are the redefined features. On the other hand, you also got some new features over here. Let's say for FaceTime, that's only specific to iOS. Also you have some Skype, that's by default also to Android, okay? So these are the features. And then under iOS, you also got different models for iPhone, and also different model for Samsung, HTC, different models. That's kind of the architecture we have. Okay? Okay, any question about this architecture here? We're going to use these to illustrate how things might be checked. Okay? Okay, after this, let's talk about some terminology. Well, in Java, you talk about the root class for every class called objects. But in Ivo, just call any, the same idea. You just get a common superclass for every class. Okay, so now the way we understand things is about inheritance. So just want to show you something here. So every time you have an arrow over here in the diagram, that means inheritance, which means iOS inherits from smartphone and etc. Okay, so now let me define a term over here. We want to define ancestor versus descendants. Okay, it's easy. Let me show you. Let me just take one class for example. Let's say I take Android as an example. Let's say this class over here. How can I know its ancestor? Ancestor is defined as follows. Ancestor is going to be every class that Android inherits from. Okay, in this case, it's going to be just smartphone. That's an ancestor. Okay, also includes itself. There will be a reason for that. Okay, so now ancestor for Android is going to be Android itself and also smartphone. Okay, so these are the two. Okay, what about, let me just show you another one. What would be the ancestor for iPhone 6s over here? Ancestor. How many ancestors are there? 3, right? So you got iPhone 6s, you got iOS, you got smartphone, all the way up to the root in this hierarchy here. That's the ancestor. Okay? So what's so special about ancestor? Okay? This is how you should think of it. For example, if I have iPhone 6s, what would be the expectation for iPhone 6s? What features can I call on iPhone 6s? Basically, all the features are accumulated along the way to the top, right? So you can call Surf Web, you can call FaceTime, also you can call Dial, you can also call Surf Web. Yeah, well, Surf Web is already there. So these are the 3 features you can call, right? So these are the 3 along the way of the ancestor path, basically. Okay, that's about ancestor path. Okay, well, let's talk about, yes. 6S, including itself. Okay, that's what that's. Yes. Yeah, but I'm just saying what. Yeah, you can. Well, technically, well, I'm just saying for the purpose of our discussion, let's assume when you say ancestor, it includes itself. Yeah. Okay, good. Now, let's talk about another one. Descendants, kind of the opposite direction. Descendants. What about descendants for Android? Basically, that simply means all the classes that either directly or indirectly inherits from Android. Or another way, all the classes that will accumulate or inherit some code from Android. What would that be? Yeah, basically all the branch over here, right? You can see this part over here contains all the descendant classes for Android, including itself. Okay? That simply means whatever features that are actually available for Android is guaranteed to be available for all the descendant classes as well. Okay? That's what we're talking about here. Okay, clear about ancestor versus descendants? Okay, good. Now, after that, well, what I would do is, let me try to make sure you understand descendants here when you study the slides. Okay? some class inherits all the features from its ancestor classes. For example, you can see that over here, iPhone 6s inherits all the features from all its ancestor, as we said before. Okay. Now I want you to make sure I understand this. I say the instances of this particular class has wider range of expected usages than its ancestor classes. So what do I mean wider expectation? It's really important to see. Okay. Let's see, for example, let's say iPhone 6s. iPhone 6s apparently inherits the surf web, FaceTime, and also dial. iPhone 6s can also define some iPhone 6s specific feature, right? Okay. Let's say, for example, Force Touch, for example. That's something that's only available for iPhone 6s. But it is not available in any of its ancestor classes. Because remember, whenever you are introducing a new subclass, not only that you can redefine the features that's inherited, you can also add new features. That means you are creating more expectation for this particular type. Okay? That's something I want to make sure you understand. Okay? So you can just add new expectation. Okay, like that. Okay, that's about it. Okay, basically, that's exactly what I said. So now what we should do is talk about some rules. I want to talk about something about substitution, okay? So let's see just one example right away. When expecting a student object, you can substitute it with either a resident students or non-resident students. So what do I really mean by this? Okay, let's just go back to our student resident students class. Okay. Okay, what I will do is I'll go back to the iPad over here when we talk about substitution. Okay. Okay, so let's just use our original example over here. Okay, we have students, we have resident students, we have non-resident students. Okay, and we have name, courses, register, and also we have tuition. And also we have tuition here, and also premium rates, set premium rates. And also here we got tuition, discount rate, and set discount rate. Okay. Whenever we are trying to do any assignments, thinking this way. We have seen this already, but just another angle to think of it. If I have like this, S of type students. Okay. Let's say this is how we declare over here. Whenever I'm trying to do the following, let's say RS of type resident student as well. Let's say we got these two declarations. When I say S is assigned to RS, we say that it is okay, it is valid, it should compile. You can think about we are basically doing some substitution. Let me write it out for you. Let's think about it. When expecting a students, and the reason I'm saying students over here is because for S, its static type is simply just a students. So we are expecting that. Okay? Now, whenever you do an assignment, that means you're trying to reassign this variable to somewhere else. So you're substituting it for something else. Okay? When we're expecting a student, you can substitute it by any of its descendant classes. Okay, notice I'm using the word descendant over here. Okay, so now you can see that the way we decide whether this assignment should compile or not, you can see RS over here. Let me use a different color here. So RS is of type resident students, right? You can see on the left-hand side, we have students. On the right-hand side, we have resident students. How do we decide if this line of assignment should compile? Here's the rule. If you try to do this assignment here, you are trying to substitute students by a resident students. And we know that you could do it because whatever you expect on students, it's guaranteed to be available on resident students, but not vice versa. Okay, so this will work. Similarly, if you also tried another one, NRS, and then NRS over here, and you can also substitute S by NRS. Okay, so every time you see any assignment like this, that's how you decide, how you determine. Just see the static type for the right-hand side, and see the static type for the left-hand side as well, and see if the right-hand side. Well, how about we just see one example? Let me ask you this. Let's try. Smartphone. Let's say Samsung. And then I have A, Android. And then I got another one, G, Galaxy S6 Edge. Okay, let's say we got these three variables. Okay, let me test you over here. Let's get on into more example here. If I say SP is assigned to A versus if I say A is assigned to G and also A how about that? These three. 1, 2, and 3. Okay, let's try to see why, okay? Apparently, well, if you only want to decide whether one thing will compile or not, only look at the static type on the both sides. And to see the right-hand side is a descendant class of the left-hand side. Let's see. For the first one, what we can do is A is Android over here. SP is Samsung. Basically, we're asking, is Android a descendant class of Samsung? Nope, so that wouldn't compile. Okay. What about A is assigned to G? In this case, G is actually over here, and then A is Android over here. In that case, will it compile? Yes, because this is a descendant class of that. So that'll be okay. Okay, let's do one more. Just make sure you're familiar with the check. What about this one here? SP is assigned to G. SP is Samsung over here. And G is Galaxy over here. Would that be okay for this one? Yes, very good, thank you. That'll be fine. Because Galaxy is really a descendant class of Samsung. Okay, that's kind of the thing you want to know how to do, okay? All right, that's good. Okay, that's about substitution, which I just mentioned. Okay, and this is the rule. Whenever you're trying to do any substitution, you want to make sure you're expecting some object of type A, you can substitute it by any descendant classes. Let's say if I am expecting, for example, smartphone, I can substitute it by any of the descendant classes over here, including itself. That's what it means. Okay, good. Okay, good. Let's go on. Okay. Let me see if there's anything more to say for this. The static type. After declaring that. Let's see some example over here. You know what? I'll go back to this, but I'd like to go directly to the cast over here. And think about it. Because I want to show you the cast syntax, which might also be useful for your lab 2. Okay, by the way, before I go about the cast, so these are the concepts we should know. Polymorphism versus dynamic binding. Let's define them, okay? So polymorphism simply means an object may have multiple possible shapes, which means at the runtime, an object of static type students might be of dynamic type, maybe resident students or non-resident students. That's multiple shape. That's how you can declare. And polymorphism is specifically useful later on when we talk about several design patterns, where you have something called polymorphic array. You have an array of students, let's say, for example. And what can be stored into the array? It can be a list of resident students, or a mix of resident students and non-resident students. That's kind of the thing we'll get into when we talk about design patterns. Okay. Dynamic binding simply means when you try to call a feature that's already available. For example, let's say this. If I say this, in general, if I say S of type smartphone, and then let's say I do something over here, some code. Now, if I say S dot simply surf web. Now the question is, what would be the version of surf web that's being called? How many surf web do we have? How many versions? Well, apparently we only got 3, right? Well, actually only, yeah, over here, that's redefined for iOS and also redefined for Android. We got 3 versions here. But which version is it going to call? Do you actually know? Yeah, exactly. It depends on what the dot 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 is going to set things up, right? So if I ask you this question later, what you should do is look at exactly the code over here to see how objects are reassigned. And then right at this point, what does S point to? If S is pointing to some iOS descendants, of course it's going to call this version over here. If S is pointing to some descendants of Android, it's going to call this version over here. It depends. Okay? Yes? No, the compiler cannot do that in general, because the dot 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 over there can be any arbitrary code you can write, including loops. So there's no way to tell.
It has to be the last one.
Huh?
It has to be the last.
The last one, yeah, exactly. Yeah. Okay, let's go to a quick example about cast. Okay, that's the dynamic binding. Okay, this for this we have gone through already. Okay, what I want to do is, so this example we also talk about just for students example. I want to go to the cast directly. So now, again, let's just review this code fragment here. Let's say we have Jim being students, we have RS being resident students. And now Jim is pointing to a resident student's object after this line. Okay? And then we say RS is assigned to Jim. We know that we cannot do it, right? Because, well, according to what we just learned before, why would this not compile? This line here. Yes? Yep, something like that. Because the static type for Jim is actually students, which is not a descendant class of the static type for RS, which is resident students. That's the whole reason, okay? But now, if I try to follow it to say rs.set premium rates, actually, can we just ignore line number 3 just for the moment? Just for the moment. If you only look at line number 4 alone, would it compile? Only line number 4 alone. Well, again, to decide, think about the expectation for RS. RS has the static type resident students. The resident student definitely has the set premium rates defined. Agree? So line number 4 itself is okay, but it's just that line number 3 is not good. Okay? And the reason that line number 3 is not very flexible over here, you can see, think about this situation over here. We know pretty well that from line number 2, what I will do is I will illustrate this, and then we'll go to the syntax for cast. Okay, let me just draw it quickly on an iPad. Resident students, and then we have RS. Okay, this is a situation. Jim was declared as a student's objects. So that's the static type for Jim. But the dynamic type happens to be resident students. And now what we have is, we have another variable RS with the static type RS. Okay? What we really intend to do is this feature call. We want to say rs dot set premium rates and something. Okay? As far as this feature call is concerned, this is okay. Because RS with a static type, resident students has such expectation. But the compiler simply wouldn't allow us to do such reassignments, right? It simply wouldn't allow us because we know that students is not a descending class of resident students for the simple reason that we talk about. But it is really pointing to an RS objects. So how do we do it? Like what you do in Java. You have to do a cast, right? To really make the compiler happy, this is what we should do. Somehow we want to modify the static type for Jim temporarily and tell the compiler Jim should really be treated as a resident student rather than just students. That's something we should do. Let me show you the cast, how the cast should look like over here. You may have seen this code fragment similar to this for lab number 2 in the example database test. But let's have a look at the syntax here. Okay, and then okay, I'll just copy that to the sheets and then we'll talk. So check attached. And then we have resident students and then Jim as RS Jim. Okay, let's have a look at the syntax here. Okay. It's basically equivalent to what you do in Java, but I just want to explain. And slightly, there's a slight difference over there. And then we'll say rs dot set premium rates, maybe 1.75. And remember, rs was declared as of type resident students. Okay, let's see the syntax over here. This is how you do a cast in iPhone. Attached is a little bit similar, was basically similar to instance of in Java. Similar, okay? And the whole thing over here, check attached over here, this thing over here is a Boolean expression. Either true or false. So what it is trying to do is as follows. Basically, it's trying to see if Jim at the moment is an instance of RS. In which case, it is. If it is, we will actually do the following. We'll try to introduce a new variable, RS Jim. Okay? What we will do is, you can think about RS Jim will declare something like this. RS, okay, let me just do it. This is something that will be done for you. Okay? You will simply say this new variable here, RS Jim, has a new static type, just RS, rather than just students. So now, if you try to do this assignment over here, would it compile? Now in this case. Now think about what's happening here. The reason that we couldn't really use Jim on the right-hand side over here, which simply couldn't do it, was because Jim's static type was simply just a students. But we are really sure Jim is really pointing to a resident students objects. So what we can do is do a cast. And the cast will introduce a new variable temporarily of the right static type over here. So now, when we try to do this particular check, what we will have is this. RS Jim, the static type is simply RS. RS also has a static type RS. So now you can see this is a descending class of that. So that will work. Okay? After that, we can simply call it set premium rates. So that will do. If you really want to see what's the corresponding code for Java, let me show you there, and then I will show you the difference. Okay, that's exactly what I said. You can also review the slides. If you look at this block of Java code over here, can any exception occur at the runtime? That's a question for you. What if Jim is actually pointing to, rather than a resident students, Jim is actually pointing to a non-resident student objects? In that case, do you think any line will actually go into errors at runtime? No? Yes?
So I don't think it will because one of the casts was false and the program was run.
No, I'm saying for the Java code, not for iPhone. Yeah, Java. Yeah, I'm glad you talk about iPhone, but let's talk about Java for now. I want to show you a difference, actually. Yeah. Okay, now how about this? Yes, go ahead.
Compile because a non-resident student is not an ancestor of resident student.
No, actually, you will compile. I'll talk about compilation rule for CAS.
It will like do a runtime error.
It will be a runtime error. Okay, let me just show you very quickly, and then I'll go into this in detail next time. Okay, so basically what's going to happen is, let's say at this point over here, Jim was actually pointing to a non-resident student's objects, in which case we are trying to cast that into some unrelated class resident students. So we might have class cast exception. Okay, that's what happened in Java. However, in the case of the iPhone, as you said, if we simply try to do this cast over here, where Jim is simply not an instance of resident students, in that case, this attached expression here will just be false, which means you will just bypass the if branch. You wouldn't even go there. So what I want to say is, whatever you will, however you're going to end up with as a class cast exception in Java, it wouldn't be the case in iPhone. They just return false for the Boolean expression. Okay, so I would say that's something you want to think it over during the reading week. Okay, and let me just see what else to say. We do have some more rules to talk about. I'll do that after the reading week. Okay, but I will finish earlier today. Okay, yes, I'll take question first, and then I'll tell you what I want to do. Yes.
For that Java code you showed,
Yeah.
that was an if statement, right? So if
No. Okay, guys, just let me finish a few things. If you look at the Java code over here, yeah, but you can see that the Java code over here, actually I meant to get rid of that if statements. Yeah, okay, I'll fix that and then I'll review that next time. Okay, guys, any more questions about the slides or topics that we talk about?